Well, here we go. This is a video about writing chemical equations, and you are watching this because A, you desire to be less ignorant, B, you want to learn a foreign language, C, I want to impress my boy or girlfriend before prom, or D, the master told me to. Well, I think you'll be able to figure out what the correct answer is. So, let's get going. Important vocabulary that you're going to need to have here. We talk about an equation, and that is simply the condensed statement of facts about a chemical reaction. It's using the symbols off the periodic table, compound formulas, and some of the other symbols that we'll add to it to incur more meaning. Reactants are things that we combine together to make products. Reactants are written on the left-hand side of the arrow. Products are written on the right-hand side of the arrow. A word equation is what we're going to be starting with tonight. And it's simply a sentence describing a chemical change using the names of the reactants and the names of the products. And coefficients are numbers that we're going to be using that go before any substance, and the purpose of using coefficients is to balance a chemical equation. And I know you did all of this in ninth grade, so I am not telling you anything new here. All right, let's think of your Bunsen burner. How would you describe the reaction that takes place when you light it? Okay, so let's start with the word equation. Methane burns in air to produce carbon dioxide and water vapor. That's what's going on when you light your Bunsen burner. So the first thing that we'll do is we're going to start with what we call a skeleton equation. And what we're going to do here is we're going to change the words to symbols. So methane becomes CH4. Oxygen gas becomes O2. And let me just say something about oxygen gas. There are a number of elements that don't exist by themselves. You've got O2, you've got N2, H2, I2, Cl2, Br2, and I2. These are the 7, and we call these diatomic elements. And they show up in a chemical reaction. We have to write them like this. I can't just write O. I would write O2. So going back, we've got oxygen as O2. Carbon dioxide is CO2. Water vapor is H2O. So I write it. My reactants are methane and oxygen, so CH4 plus O2. Then my reaction arrow, CO2 plus H2O. Now notice this is not balanced. I've got 1, 2, 3 oxygens over here and only 2 oxygens here. I've got 4 hydrogens and only 2 hydrogens. So we're going to need to balance this. Now, here's a truth for you. The number of atoms on each element must be the same on each side of the reaction arrow. And you ask the question, why? Well, it's because of what we call the law of conservation of mass. And we are going to probably be talking about this with the lab that you did on Friday. But what we're going to do is we're going to use coefficients to balance this reaction. And the method that we're going to teach you is called balancing by inspection. Doesn't that sound exciting? So I'm going to inspect this equation. And I look at it and I've kind of noticed I've got 4 hydrogens over here and only 2 here. So if I put a 2 out in front, that's going to give me 4 hydrogens. It also gives me 2 oxygens. and I've got 2 oxygens here, so that's 4 oxygens. So I'm going to come back over here and put a 2 there. Now I look at this. I have 1 carbon, 1 carbon, 4 hydrogens, 4 hydrogens, 1, 2, 3, 4 oxygens, 4 oxygens. Guess what? I am balanced. Wasn't that fun? It was easy too. And here's a visual way of seeing it. You've got your methane plus 2 molecules of oxygen. It's going to produce a molecule of carbon dioxide and 2 molecules of water. Now, some of the additional symbols that we'll use if I ever ask you to do a complete chemical equation, some of the little ones are an S represents something that is solid, an L liquid, a G gaseous. AQ, which is aqueous, or if you're in Mr. Meehan's class, it's going to be aqueous, means it's dissolved in water. And PPT means precipitate, and that's a solid that's formed during an aqueous solution reaction. And we'll talk about that. It's a kind of a special case. And so down here at the bottom, you know, when to use L, when to use AQ. Sugar with an L after it would be melted sugar. Sugar with an AQ would be sugar that's dissolved in water. Got it? So, if we want to write our equation correctly, the most complete way to show this change would be as follows. I've got CH4, that's methane, and this is a gas, plus 2 molecules of oxygen, which is also a gas, reacting to produce 1 molecule of carbon dioxide, which is also a gas, plus 2 molecules of water vapor, which is also a gas. And that's it. So, now it's your turn. I've got another reaction for you. This is actually one that you're going to see me do outside. Aluminum metal reacts quite violently with iron 3 oxide to produce aluminum oxide and molten iron. So given that information, can you please write the equation and balance it and use the correct symbols? Thank you.